Given some equations of motion for constant acceleration in this question, also known as kinematics formulae or Suvat equations. They mainly come into mechanics in A-level maths, but they're touched upon at GCSE. And so what you need to know is that u is the initial velocity, v is the final velocity, a is the acceleration, s, that's maybe the trickiest one to remember, is the displacement, which is slightly different from the distance. I'm going to call it displacement here because we've got some negative acceleration. So you can basically, the distance is how far you travel. So if I'm going from here to here, and this is 10 meters, then I've traveled 20 meters. However, the displacement at the end would be 0 because I've gone 10 meters and I've gone minus 10 meters. So it has a direction as well, as does velocity, to be fair. And then t is the time taken. So make sure that you're familiar with these, because otherwise these equations won't make any sense. But we're given, therefore, that u is equal to 20, a is minus 8, and after t seconds, the particle has travelled 25 meters. So s is, technically this is the distance, but in this case it's also the same as the displacement because it won't be going back on itself because it hasn't had time, I don't think. We'll find out. S is 25. I think we need to assume that that is also the displacement. So show that this is true. We're going to look at the formula and decide which to use. I want one with t in as well. So it's going to be this one because I don't know what v is, and so I want to leave those two formulae alone. So I can write down that 25 is equal to 20t plus a half times minus 8 times t squared. 25 equals 20t minus 4t squared. This is looking good now. I've got all the coefficients. I just need to get it so it looks like the one above. So I can basically add 4t squared to both sides, minus 20t from both sides. I've still got my 25 from before, and that's equal to 0. Okay, so even if you couldn't do this, if you had I have no idea what this is going on about, okay, I've tried to explain what's going on, you can still do part B. You need to solve this equation. It's a calculator question. Will it factorize? We can try it, or we can just jump straight to the quadratic formula. I'm just tempted that it's going to factorize, so I'm going to give that a go. Let's see. So if I try 4t in t, and then need 5 and 5, that's not going to work. Oh, I don't think this is going to work. So next step, try 2t and 2t. If I did minus 5 and minus 5, that will work because I'll get positive 25 and I'll get minus 10t and I'll get minus 10t. So that would give me minus 20t. And therefore 2t minus 5 is 0. T is going to be 2.5 seconds. And yeah, that's not going to be enough time to make it go back on itself. I mean, we had to assume that throughout. Basically, what I'm trying to say is that I kind of made a bit of an assumption at this point because it told us the distance, and sometimes the distance is not the same as the displacement. But we're okay here. It's going to be 2.5. Of course, you can use the quadratic formula, and you should get the same thing. I'm not going to go through that here. Show the particle is stationary when it's traveled 25 meters. All right, so now we've still got that u is equal to 20. That was my initial velocity. I've still got that a is minus 8 from before, but now, and I've still got that s is 25. Okay, so actually it is the same conditions, and now I want to know v. So I can either use the time from before, or I can use v squared equals u squared plus 2as and avoid the time. Now I'd say it's slightly easier to use this v equals u plus at. The only thing is that, what if t was incorrect? Then I can make a mistake. But the thing is, I'm showing that it's traveled 25 meters. sorry, I'm showing that it's stationary when it's traveled 25 meters. It's probably the best one to go with because then I can even check my answer. I'm expecting to get v is equal to 0. So v equals u plus at. It's going to be 20 minus 8 times 2.5, and 8 times 2.5 is minus 20. You can check that, but if I double it, I get 16. If I halve it, I get 4. 16 plus 4 is 20. And then I just need to conclude. So the particle is stationary. And this is great because I even know my answer to part this one here has got to be correct as well. Okay, essentially we've got, I mean, just to finish this question, we've basically got a particle, it's going this way, but it's slowing down, and after it's traveled 25 meters, then that would be when it would start going back on itself and then accelerating that way. But we don't ever get to that point. We just get to the point where it's stationary.